Hi, I'm Paul Bailey, and this is the linear regression portion of the introduction to PIAC. So what I'm going to show you now is the function lm.sdf that allows you to run a linear regression in a way that takes account of the plausible values, the survey weights, and correctly calculates cluster robust standard errors. And so there are three components that we're going to talk about for lm.sdf. It's a lot like the lm function in R. It has a formula that works in the same way as R's formulas do. It has a data set, and then it has weight variables, which is also similar to LM, but it works a bit differently because it's going to use replicate weights. How do I use a function or a formula, sorry, in R? The way I do that is that I have my dependent variable, a tilde, and then a list of covariates. And so we're going to do a regression on the bottom here with numeracy predicted by the highest of mothers and fathers' levels of education. So we showed the levels of that and our raw n sizes here at the top. And then we run that regression. And just like in base R, we don't see anything now. We have to call summary on LM2. And when we call the summary on LM2, it gives us a bit more information. It tells us how many replicate weights were used, how many people from the PIAC sample are actually represented in this regression. And then we get a standard coefficients table, um, which shows the coefficients or the estimated values, the standard errors, the t statistics, and then something new, which is degrees of freedom that change by covariate. So why would the degrees of freedom change by covariate? And that's because this is a survey sample. And so the extent to which the covariates vary across the strata can vary. And so we can get different numbers of degrees of freedom per covariate, depending on if it's all in a few strata, it would have a lower number of degrees of freedom. And if it's varying across the entire sample, it would have a higher number of degrees of freedom. And then at the very bottom, multiple R squared. Um, Here's a bivariate regression where we're adding in the keeping up to date on learning to the regression, and then the output for this just adds the covariates for that additional uh, the portion of the regression. And then, like I said, just like normal R, we can do multi-way interaction. So here we're using these two variables and then putting them together with a colon, and that will give us interactions between the two covariates. That doesn't show up on the screen, so you're going to have to check this for yourself in order to see what that looks like. Thank you.